Today we're learning about buoyant force. We have three liquids with us today. We have vegetable oil, we have water with food coloring, and corn syrup. We also have four different objects with us that we will be dropping into the cup. As you can see, the four items have dropped at a different level each time, and that is because of buoyant force.
But how does buoyant force work?
Buoyancy goes hand in hand with water pressure. In this picture, we have an object that is completely submerged in the water. From both sides, from left and right, we have two forces that cancel out with each other because of the same magnitude and different directions. On the top, we have a smaller force than the bottom force because pressure increases the deeper you go into the water, which results in a net buoyant force, which goes up. Which there is a free body diagram right here, where buoyant force goes up and force of weight goes down.
Well, that is so interesting, but how does it apply to the demonstration?
So let's take a look at what we did earlier. We had the three different liquids, corn syrup, water, and vegetable oil, all separated based on this being the most dense and this being the least dense. So what were those objects doing? What were those objects doing? We had the iron rod that went straight down to the corn syrup. It went straight through the corn syrup as its force of weight was greater than the force of buoyancy acting on the iron rod. Then the golf ball. The golf ball went into this little water area. It couldn't go into the corn syrup because its force of weight was not greater than the force of buoyancy that the corn syrup exerted on the golf ball. Same that goes with the peanut that was in the vegetable oil. It wasn't great enough to go to the water. Its force of weight wasn't great enough to go in the water, but the water's buoyancy force was great enough to keep the peanut here. Then the marshmallow, its weight was so little that it couldn't even go into the vegetable oil. Alright, let's go look at why this golf ball sank in the water and not the corn syrup. So, let's get our equation down. Force of buoyancy is equal to rho times volume times gravity. So, we have a rho of water, which is 1,000 kilograms per meters cubed. Then we have a rho of corn syrup, which is 1,380 kilograms per meters cubed. Then we have our volume of the golf ball, which is 0.00004593 meters cubed. Then we have our mass of our golf ball, which is 0.045 kg. So, let's go take a look. Force of weight of the golf ball first. So, we got our mass times our gravity. We got 0.46 newtons. So, and then let's go to the force of buoyancy. So, we have a rho, which is 1,000 kilograms per meters cubed, which is our density of water. Then we have our volume displaced, which is the 0.0000 long number. Then we have gravity, and we got 0.45 newtons. So we're going to take a look. The golf ball sank because its force of weight was greater than the buoyancy force of the water, which is right there. Now, why didn't it do it in the corn syrup? Let's go take a look. The force of buoyancy by the corn syrup is this 1,380 kilograms per meters cubed, and then we have our long number of the volume, and then we have our gravity, which is 0.62 newtons. So the golf ball didn't sink into the corn syrup because this number, our buoyancy force, was a lot greater than our force of weight of the golf ball. And then you get this free body diagram of the force buoyant is greater than the force of the weight.
Well, this is all so interesting. One question I had is why you can't swim in some water, only.
I believe that Mr. President there at the end meant to say Fortnite, but his question is, why does the water in Fortnite not allow you to swim on, but later on you can swim? And we can solve this question by solving for the buoyant force, which is the equation. Buoyancy equals rho, so the density of the object, times gravity, times the volume displaced by the fluid with the object in there. And what we find is that if our rho right here goes down, then our buoyant force will also have to go down. And this is because every single Fortnite person has the same volume and the same gravity, or gravitational pull. So the only thing that can change is the density of the water in Fortnite. So what we find is that the density in the water earlier in the Fortnite seasons that you cannot swim in have a smaller density, therefore a smaller buoyant force, which means that you just sink and your character will die. And later on, let me just I don't know why it's like that. And later on, if we increase the rho, then our force of buoyant will also go up.
Wow, I learned so much about buoyancy. Thank you, pupils of Mr. Willard.